Okay, let's continue. We are now at the analysis part of the lecture. So we are given here, we're supposed to draw a quadrilateral MILE with the diagonals ML. Now there's a line here above, and IE, line IE, bisecting each other. So in this drawing, okay, this is the quadrilateral MILE, and then you are going to draw a diagonal from M to L. So this is the line, okay, and then another diagonal from I to E. And here it is mentioned that they are bisecting each other. So what does bisecting mean? Okay, so they will have a common point where one line passes through another line at a single point. And when we say bisect, this point, okay, from this point to one part of the line, okay, it is half of the total length of the line. So for this diagonal, okay, this point here in the middle is the midpoint of line M, and then this point, and then it is also, and this will be equal to this part of the line here from the midpoint to L. Okay, the midpoint cuts the line into two congruent sides, okay, or line, two congruent line. Next, if the two diagonals bisect each other, okay, this point here also is the midpoint for line IE. So that means I to the midpoint will be equivalent to the midpoint to letter E. Okay, so we'll just put a marking to identify which lines are congruent to each other. Okay, so remember, you still have a quadrilateral. Next, mark the intersection of the diagonal as S. So this midpoint here of both lines will be marked as S, where the two lines intersect. Okay, now you are being asked, why is angle 1 congruent to angle 2? Okay, when you are to write down the reason, okay, you have to find out what is the relationship of angle 1 to angle 2. So looking at the illustration, okay, what two angles are formed when two lines intersect, and their position is like here at like a funnel, or like a funnel, or like a time, what do you call that? I forgot. Okay, so here, this one is angle 1 and this is angle 2. So if you look at the two angles, okay, they are actually what you call vertical angles. Okay, vertical angles, where they have a common vertex here. Okay, they share a common vertex. So why then? So angle 1 is congruent to angle 2 because what? Vertical angles are congruent to each other. Okay, so why is angle MSI congruent to triangle MSI congruent to triangle LSE, triangle LSE? So, looking at the markings that you have seen, okay, you will find that this line here is congruent to this line here of the other triangle, and this line here of triangle MSI is congruent to this line here, or this side of this other triangle LSE. Okay, so, and the vertical angle is congruent here. So what kind of postulate says that these two triangles are congruent given the three parts that are congruent to its corresponding part of the other triangle? So you will see that this is side, angle, side. So that the postulate SAS will tell you that these two triangles are congruent because you have two sides that is corresponding to the other side of the other triangle that are congruent, and you have an included angle of each side that is congruent to its vertical angle of the other triangle. Okay, so that's the reason why. So now so we've answered 2, okay, here. So why is angle 3 congruent to angle 4? So 3 here, okay, is an angle of triangle MSI, while 4 here is an angle of triangle LSE, which is congruent to this first triangle. Okay, so look here, this is side with this length, okay, and this is its angle, and then this is the side with this length, and this is the angle here. 4 is the angle here. So that means 3 and 4 are corresponding angles. Okay, so this means this angle here and this angle here are the corresponding angles of the two triangles. So it is safe to say that angle 3 is congruent to angle 4, okay, because corresponding parts of congruent triangles are congruent. So that's the CTC, corresponding parts of congruent triangles are congruent. So that's the postulate that makes these two angles congruent. Okay, so what can be said about MI, and this is line MI and LE? Okay, so we've already proven that these two are congruent triangles, and this MI correspond to this LE part, okay, of the other triangle. So using the same postulate CTC, line MI is congruent to line LE. Now, what condition makes quadrilateral MILE a parallelogram? Okay, what condition? So let's investigate further this illustration. Here you have a diagonal here, okay, and you have angle 3, which is congruent to angle 4. So these are what you call, if you take note of this line, MI and LE, this is the alternate interior angle, okay, formed with this diagonal that intersects line MI and line LE. So if you have alternate interior angle, okay, of a line intersecting two lines that are congruent, that means that this line MI is actually parallel to this line LE. Okay, so yeah, so then what condition makes quadrilateral ME a parallelogram? If you go back to what the conditions that make a parallelogram congruent, okay, let's go back to the abstraction part. Okay, so here, okay, you should have a pair of opposite sides that are parallel and congruent. Okay, so this is the condition that satisfies our analysis that quadrilateral MILE is a parallelogram. Okay, because we have proven that these two sides are congruent to each other, because congruent parts of congruent triangles are congruent postulate, and because of this alternating angle formed by the intersecting diagonal that intersects the two sides, okay, that are congruent. So the condition that the MIL is a parallelogram because you have two opposite sides that are congruent and parallel. Okay, so that's it.